Yes, thank you, Chris. I can take over from here. Um, as you mentioned, Chris, value assurance is a process that is played at each stage in order to make sure that the team can go to the next stage in a safe way. And of course, within this, there is also the big important part at the early stages, which is all around the design. So one of the tasks of value assurance is to make sure that the team is developing the design as best as it can be. Now, on this page, you see maybe something that you recognize. All of these that are based on my experience are leading to eventually to high capex, high opex, slow ramp up, and long payback of our investment projects. Gold-plated design, it's something that happens quite frequently. Copy-paste from the past, people are feeling safe because it's a solution that is already working. Often there is not enough visibility on the, can you go back please? Thank you, stay here, thank you. Often there is not enough visibility on what is happening outside in the market. So the economics of that investment are not clear enough. The project team, which is often a technical team composed by engineers, it's focusing on physical assets only. The operators that will need to run that plant are involved just at the end and only to operate the equipment, but are not involved into giving input on how to design that equipment, for instance, to make it maintainable. The success is measured by having achieved a certain capex budget and delivering on time, but the concept of value, it's not known often. And complexity, it's also often used to mitigate risks. All of this is something that it's not making the design better, it's actually creating those risks that you see on the right-hand side. If we move to the next page, I just want to frame the design optimization and to say what do we mean with that. We mean design optimization as lean principles applied to project design for waste-free industrial investments and optimized operations. I took the liberty to read this because I think it's an important statement that considers everything what we have in mind when we talk about design optimization. So first of all, I use the word lean because we want to consider two very key principles that are taken from the lean philosophy from the Toyota production system. One is we put ourselves in the shoes of the customer, and in an investment project, the customer is the commitment. So that one that it's originating the need can be the business, can be operations for smaller projects eventually. But we need, first of all, to deliver something that is tailored to the needs of that customer. And the second is we want to avoid waste, which means avoid waste delivering features that are not requested by our customer, and of course will not even be ready to pay for that. But we also want to avoid for our project team to do rework for developing something that then is not at the right quality level and eventually at the stage gate with the value assurance will be rejected. Or we don't want to have waste in terms of, for instance, problems in communication. That are creating then again misunderstanding among the project members. If we talk about design optimization, which is a phase that is following concept optimization, here we are looking at questions to be addressed that could be how can we improve the outcome of the concept and optimizing the design. But also, I want to state there is something on the concept as well. When we do design optimization, we also start from the concept and we want to make sure that among the different alternatives and still focusing on what the customer wants, even the concept is the one that can provide the best outcome, and therefore it makes sense to optimize the design so that go a bit deeper in the concept in order to optimize it as well. Next, please. There are a couple of guidelines that we are following when we do design large investments. One is, it's not just physical assets. So you see here there are three bubbles. In a production system, we also need to consider that beside the resources, which are the manpower, which are the machines, the space, the material, we also have processes that are those ones that are organizing our resources toward the production of the end product. And of course, we also have people, which are not considered as just man hours, but are people with their feelings, with their mindset, with their competence. We also must consider that the complexity of a certain physical system will require different competencies on the people side. So it will be a mistake to forget about the people part and just plan around a technical physical system. So therefore, we start with equipments and buildings, but still at the early stages, we need to ask ourselves, what will be the organization that will run these assets? Just to make an example, if I have to organize the maintenance and to decide if I will have in the layout of the factory a central maintenance workshop, or if it will be decentralized. This depends a lot on what type of maintenance do I need to bring to the machines, close to the machines. Do I need to have very quick troubleshooting? And do I have maybe the competencies in the production team so that I can have a maintenance ambassador at each production team to do first diagnostic and first repair? In that case, maybe I want to have a decentralized, smaller maintenance workshops. On the opposite, maybe I want to have, because it's a very complex asset what I need to maintain, and therefore I need to have a centralized specialist team. In that case, I need to have a central workshop. This will, of course, affect the layout of the factory. So one last comment, it's of course, the more the complex it is, the more will be also difficult to ramp up such a system. So the design probably will also be affected. Thank you. The second guidelines belief that we have is it is easier to design and to optimize an investment when we divide it into different aggregation level. And here we are introducing the concept of macro, midi, and micro levels. Here you see an example from the extraction industry. The benefit of breaking a project in this way is that you can treat each part separately. What I mean is, when we talk at macro level, we are talking about characteristics of the whole system, which could start with what is the capacity, which could go in terms of what will I produce in-house, what I will outsource, what is inside battery limits, what is outside, what level of reliability I want to have out of that system, what type of products will I need to produce in this production system. Once I have clarified and optimized this level, then I can go one level deeper and I can work at department level. Typically, the MIDI level is creating boundaries where between one and the next there is a decoupler, can be a buffer, for instance, so that each of these MIDI scope can work more or less independently. So if you go and optimize the MIDI level, you have the chance to do it in parallel. So you have from the macro, the guidelines or the new optimized guidelines, and then you can work and you can use your teams to work in parallel to optimize the different MIDI scopes. The next level, at micro level, it's more on the equipment. It's then less talking about organization, but it's more something that you analyze in terms of equipment. So what type of machines, what type of equipment are you using? Do you use backup systems, standby pumps, for instance? So this is more on a micro level. It depends. Sometimes it's a level that will not give a lot of opportunities. Or if it gives a lot of opportunities, it takes a lot of time to go through it completely. But still, it helps dividing the overall design into 3 levels, so you can really do working in parallel. As we have seen in the previous pages from Chris, and talking about value assurance, a design optimization activity, it's something that you put indeed into each stages at the beginning of development of an investment, and you keep doing it for the stages that have influence on the design. So here we have tried to use these circles in the middle of the page to represent exactly that. So it's not something that you do at the beginning or at the end. At the very beginning, it could be too rough what you optimize, because it would be probably still based on very high level assumptions, and maybe even the CapEx estimate are not solid enough. Of course, you don't want to do it at the very end, because eventually you would need to redo a lot of things. So it's a process that it's going on through the design phases. And it's also important because in a project like this, which is typically taking several months or years, assumptions that have been decided at the beginning might change. Think about market conditions. It could develop differently as it was assumed at the beginning. Therefore, it's important. And what is important to do? It's important to continuously review the project's requirements and the design. We have here 4 recommendations in order to make sure that the design is consistently as the best as it can be. One is, we must still make sure that the scope is agreed, and there is a clear distinction between must-have and nice-to-have. Often, in my experience, I think it's not surprisingly for you guys, we have seen that during the development of a process, of a project, scope has been increased. Think about sales department comes and say, I also would like to produce that product, which was not in the original envelope, but it's still something where I see that there is a market. Good. This is something that needs to be clarified, because this additional product might create a lot of additional investments, and maybe the contribution margin is not so high. So it's something that must be scrutinized very clearly. Solutions that are alternatives must be also ranked in an objective criteria. We use net present value. We try to make alternatives competing to each other by looking at which alternative is increasing the NPV at most. The third is, we need to make sure that decisions are, that informations are always at the latest stage, and everybody is sharing the same information, which is leading to the 4th point, which is involving all the key stakeholders in participating and challenging the design. Sometimes the silo working mode is creating misalignment between informations that are used to develop the project. I've seen in my past for an automotive factory, which is typically followed in 4 departments: the press shop, the body shop, the paint shop, and the assembly. Different assumptions in terms of what is the capacity of each of these departments. And therefore, there was a clear misalignment and a clear waste, because some department was able to produce much more than what the bottleneck could. So this is something that we want to repeat during the design phase several times, making sure that we keep all the design at highest value as possible.